Welcome, math group. We are going to talk about some true or false statements and something called counterexamples. To get us started, if we add two even numbers together, the sum will also be even. Is that a true statement or a false statement? One way to start tackling this is by writing down some examples. We need to take two even numbers and add them together, and then look to see what the sum is doing. So maybe I pick 4 and 10 and add them together. I get 14. That's two even numbers added together, and I get a sum that is also even. And I can pick some other ones. 6 plus 20 is 26. 6 and 20 are both even, so is 26. Let's see, maybe we try 100 plus 42. Those are both even numbers. The total is 142, and that is also even. And so it appears that when we take two even numbers and add them together, the sum is also even. So I'm voting for true at this moment, and I think this statement actually is true. It could be proven for sure if we had a few more techniques available to us. This kind of technique where we list a bunch of examples and come up with a response, that is inductive reasoning. So we have inductively decided that this statement is probably true, and I'm letting you know that it is for sure true. I have a couple others waiting for us. These are also true or false statements. So maybe take a moment and see what you think in each case. For this first one, the square of a whole number is always even. So we're supposed to take a whole number, maybe like 4, and square it and see what the result is, whether it's even or odd. So 4 squared means take 4 and multiply it by itself, and that gives us 16, which is even. If I took 10 and squared it, 10 is even. It means 10 times 10, and that would give us 100, and that is also even. So this statement is looking like it might be true. Let me try another one. Maybe 5 squared. 5 squared means the same thing as 5 times 5, which is 25. 25 is odd. So this statement is not always true. That means we would label this as false. It is not always the case that the square of a whole number will be even. And this example, where we said that 5 squared was 25, that is called a counterexample. It is an example that shows that the statement is false, a counterexample. So if you are going to work on true, false statements like this, and you label something as false, you want to make sure that you have a counterexample to back up your response. For a true statement, like the one that we had before, you would probably just have a list of several examples until you decide that you are in a situation that's true. We don't often do formal proofs of true statements in Math 115. Second statement here, if we multiply two even numbers together, the digits in the answer will all be even. There's a lot of stuff going on in that statement. We need to multiply two even numbers together. So let's do 4 is even, and so is 6. Let's multiply those. We get 24. 2 and 4, the digits in the answer, those are both even. Let's try 10 is even. Let's multiply it by 2. 2 times 10 would be 20, and the digits there are both even as well. What about 18 times 2? 18 and 2 are both even. 18 times 2 is 36. The 6 is even, but the 3 is not. We were looking for a scenario where one of the digits at least one of the digits is not even, and we have found it. This statement about multiplying two even numbers together and getting an answer where all of the digits are even, that is false. And the counterexample that I was able to find was 18 times 2. So one of your jobs in this unit is to look at statements that are asking you to say whether they are true or false. And if something is false, be ready with a counterexample to prove that it is false.